Okay, next we have what we call it the magnetic spin quantum number. As we know that there are two types of angular momentum. One is orbital angular momentum. One is orbital angular momentum L. The other is spin angular momentum S. And their sum is called total angular momentum. Total angular momentum, which we represent by J, which is equal to L plus S, the sum of orbital angular momentum and spin angular momentum. Now suppose I will draw a figure here. Suppose we have the orbital angular momentum is this one, and we have spin angular momentum is this one. This is orbital angular momentum and this is spin angular momentum. Now their sum is called, their sum is total angular momentum. So their sum can be obtained by using the vector addition by head to tail rule. So this is the total angular momentum J. Now this orbital angular momentum and spin angular momentum precess around this total angular momentum in a way like this. These are the precision direction of spin angular momentum and orbital angular momentum around this total angular momentum. Now if we apply an external magnetic field, let's suppose this is the external magnetic field direction B, then this total angular momentum also precess around this external magnetic field. So here we have the precision of total angular momentum. Here this is the spin angular momentum which is precess around this total angular momentum, and here we have this orbital angular momentum which is precess around this total angular momentum. So this total angular momentum vector also precess around this external magnetic field. Now if we take the projection of this spin angular momentum vectors in the direction of external magnetic field, suppose I take a projection here, and the projection is this one. Then this projection here, this projection which we represent by MS, is called a magnetic spin quantum number. So we can say that the projection of spin angular momentum vector along the direction of magnetic field is called magnetic spin quantum number. And it is represented by MS. Now the spin angular momentum can have only two possible values, either spin up or spin down. Like it has two values, 1 over 2 or minus 1 over 2. So we can say that the spin angular momentum can assume only two possible positions. If this is the external magnetic field B, then the spin is either up in the direction of magnetic field or it is down in the opposite direction of magnetic field. So projection of this spin in the direction of magnetic field when it is up is ms, which is 1 over 2, or the projection of spin when the spin is downward, then its projection ms will be minus 1 over 2. So these are the two possible values. Ms can have only two values, which are plus 1 over 2 and minus 1 over 2. And finally we have the magnetic total angular momentum quantum number, the seventh one. This was the sixth one, and here we have the seventh one. Magnetic total angular momentum quantum number. As we know that the total angular momentum vector, let's suppose we have, this is the external magnetic field, and here we have the total angular momentum vector, which is I represent by J. It presses around this external magnetic field in this way. So if we take the projection of this total angular momentum vector along the direction of magnetic field, then this projection from this point to this, we call it mj, and it is called magnetic total angular momentum quantum number. So this is magnetic total angular momentum quantum number. This is the projection of the total angular momentum vector J in the direction of magnetic field. And it is denoted by mj. Now mj can have values from j, j minus 1, j minus 2, 0, 1, 2, up to minus j. We can say that mj can have only two j plus 1 values, like that of magnetic orbital quantum number. So we discuss all the 7 quantum numbers here. Now we have to note 2 points here. The notes are: number first, the state of an electron in an atom is completely specified by the 4 quantum numbers. And the 4 quantum numbers are principal quantum number n, orbital quantum number L, magnetic orbital quantum number ml, and magnetic spin quantum number ms. These 4 quantum numbers completely specify the state of an electron in an atom. So we have to discuss all these 4 quantum numbers by discussing the Pauli exclusive principle in the coming videos. Thank you. This is all about quantum numbers.